Okay, so we are recording. So welcome back. I think we got everyone for today. I know Brian's not going to join us, right, remotely either? Okay, and Miriam will be viewing this later. Okay, so I'll try to, assuming no difficulties, I'll record this and post it to the same spot where all the other videos are at. So hopefully that's helpful. Okay, so before we start the new stuff, any questions on the homework that's due today? Besides what, besides not doing, besides finishing it? Okay, all right. Well, let me know if you have any questions on that. But again, that's, you can have till the end of the day to do it. Okay, so I posted some new stuff for this week. All right, so this week we'll continue with multiple regression and do a few more things by looking at binary variables or dummy variables, and also looking at correlations, which is called multicollinearity, which we kind of uh, looked at the surface last time, but we'll do it in practice today. So bigger? Oh, sure. This is just the. I'll make it bigger when I get. Yeah, I'm not. I haven't done anything yet. So yeah, yeah. But we could. Do you guys want to sit closer? I'm gonna. There's only three of you, and everyone's like, yeah. Okay. Oh, that's right. The power issue. Okay. There's no power in the floor or something? Yeah, that's not very. Yeah. You know? Okay. So why don't we, let's see. What I want why don't we get right into the assignment, and then I'll kind of put in the videos as we go along, because I want to start with just running some regressions again, and then we'll start with looking at correlations when we get to that, which is multicollinearity, and then later on we need to interpret binary variables. So I'll kind of toss in these videos as we get to the concept. So we'll start with what we've done before and then kind of build upon that. Okay. So we'll do at least um, the first one together, maybe more, but we'll see. Okay. So we've learned multiple regression. We've learned how to interpret the coefficients. We haven't learned how to add or drop variables based on significance. And we haven't learned how to reduce the model if there's some correlations. And we haven't learned how to do binary variable interpretation. So those are the three things for today. I think the best thing to do is just open up homework 3. Okay. Okay. Make this, oops, how about not that big? 150? There we go. That big enough? All right. Okay. So there's three bigger questions in this homework assignment. And you'll notice that there's a number of variables that could affect uh, the given y variable. And our goal here is not only to be just to run the model, but to figure out which variables should be left in at the end. All right, so it's not just interpret the coefficients, it's figure out the right model and then interpret the coefficients at the end. So this one I had a little description. So the first one, we're going to open up this housing prices data set. And the main thing here is to look at model reducing and multicollinearity, which is if the x variables are correlated with each other, you don't want to have that, otherwise the interpretation gets lost in the weeds there. So for this example, a real estate company that produces around a ski resort in the US wishes to improve its methods for pricing homes. Data is readily available on a number of measures, including the size of the home, location, age of the house, and a strength of market indicator. So what we're trying to do is determine which factors relate to the selling price of the home in and around the ski resort and develop a final model to predict housing. So we're going to start with a whole bunch of things, and then based on our analysis, we'll define it and reduce it if necessary to the appropriate model. Okay. So the first part will be similar. The second part, where you're doing kind of model diagnostics, is a bit different. So we're going to have a data set, 45 residential properties sold during a recent 12-month period. I'm not sure if this is actual real data, but it doesn't really matter. So we have the selling price of the home in thousands. Actually, why don't we open up housing prices? So this is week 6, homework 3, housing prices. Okay, so all the variables I read off should be here. So let's go through them and then look at them. All right, so we have the price of the home in thousands. We have the number of bedrooms in the house. We have the number of bathrooms in the house. We have square feet, size of the house in square feet. We have miles to the downtown ski resort. We have miles to the base of the ski resort's mountain. We have lot size in number of acres. We have number of cars, number of car garage, uh, age of the house in years at the time it was listed, and then number of days in house, number of days the house was on the market before it was sold. So you should be able to see all those variables in the data set here. Okay. So price, remember this is in thousands. So when we do the interpretation, that's 330,000. Okay. Not 330. Beds are pretty self-explanatory. And so you can kind of go along and just, before you do the analysis, kind of think what you might expect to see. We think that more bedrooms, more baths, more square feet would increase the price of the house, right? Because you're getting more features or bigger size. We would think because this is kind of a vacation town that you want to be closer to the base of the resort or the mountain. So you would think that the closer you are to the ski resort, the higher the price would be. Bigger acres should lead to higher value depending on a number of things. Probably more cars in the garage should increase the house. Years old is kind of ambiguous because sometimes home buyers prefer older houses based on the uniqueness, but newer houses could have better insulation. So that I'm not sure. And then days on market, um, not sure if that would have these ones I'm not sure if it would be any effect or if it would be up or down. But the other ones, you can kind of see that, how higher prices go up with beds, baths, square feet, acres, cars, and then the farther away you are from the main event, likely the price goes down a little bit. So that's our goal, to use all this stuff to try to predict this. Okay? The price is why. Price is why. Yeah. Okay. So part A, which is the first part that we've kind of done before, is let's run the full model with price as the dependent variable, the y variable, and all of the other variables as x variables, which are these that are not y. Okay. Then we haven't done, why don't we do that part first? All right, so let's start with that. Okay. So let's close this one. We're good on that. All right, so same old thing here. The only difference is we have many more x variables than we did before, but other than that, it's the same concept. So you're going to do data, data analysis, Um, regression. Okay. Y range is the entire A column. So A1 to A46. X range, if you click that, is you can try to choose everything at once using the mouse or the keyboard, but you want to choose B1. And the shortcut is Shift Control down, but you want to select this whole range. So just to look at the ranges, the Y range is A1 to A46, and the X range is B1 to J46. So all of the other variables go into X. And then make sure you click on labels so you get a label of the coefficient. Okay. Yeah. All right. So this should be similar. Let's hit OK, and we get a bunch of different things to look at. So why don't I just simplify uh, the numbers. Home tab, format cells, number, two decimals with the comma. Okay, and this is not required, but it makes it easier for me to see it. And then, yeah, okay. So, before we start highlighting things, that's the first step. So let's see if we did, no, we did not do, okay. So first part was run the full model with Y, the price variable, and then all the other variables is X. So that's what we've done here, okay? So if you did this part correctly, you should have the variables beds, bass, square feet, miles to resort, miles to base, acres, cars, years old, and then data market. Um, and we're going to do some reducing, but if you look just firsthand, it looks like beds increase the price, bass increase the price, square feet increases the price, and right, the farther away you are from the main resort or the base, it goes down. Acres increases the price, bigger garage increases the price. It looks like older houses are less pricey, even though that's going to be taken out because of significance. And then data on market is pretty small effect. So everybody got this part so far? Yeah. Okay. Now, the next step, which we have not done before, but we'll get the idea pretty quick, is to reduce the model by omitting the variables that are not significant. And then at the end of this is the final result for part A. So what you're going to do, if you just go back to here, is basically you want to cut out the variables that are not significant, and those are going to be the ones that have a pretty low t-stat. All right. And so if you look, we've got bet bass, which is pretty high. We've got um, acres, and really the thing is, you really want to do this one by one, and it's a little bit tedious. And there's other software programs that are a better job at doing this, but I kind of want to show you doing it this way. So what we want to do next is look at the t-stats, not including the intercept, and basically take out the one that's the lowest first. So you can look through them. I might as well show you like if you select uh, D18 to D26, like that range, and you want Excel just to tell you the lowest one, you could just do Home tab, conditional formatting, um, top bottom rules, bottom 10 items, and then if you just choose like reduce the 10 to 1, that will, actually, it's not going to work how I want to because it's not, the negative doesn't, okay, skip that part. What we want to do is, I guess we can just look at it. So I would like to um, maybe I'll sort them. about that.
I know that you're showing it. Can you not just delete the whole?
Well, I could, but I want to rerun the model without that you know what I mean? Yeah.
Basically, you're setting it up so it runs it, eliminating
Uh-huh.
those before we get it.
Yeah. Uh-huh. Yeah. So to know which ones to eliminate, you have to look at the whole thing first. And Excel is not the best at this process, but because it's tedious, you'll learn it. But there's other software programs that you just like hit a button and it takes it out and reruns it automatically. But for the purpose of this, I think the best thing to do would be just to better.
Yeah.
Okay. So why don't we do this? Why don't we sort this area by tstat? All right. I wanted to, but no, I don't want to do that because, yeah, we can do that. Okay. So, yeah. So why don't we choose this range, A16 to I26, and do data, tab, sort, um, and you can sort by tstat. And if you miss, I'll do the step again if it doesn't, and then hit OK. Yeah. And that way, um, you're look, even though it sorts negative to positive, but you see the ones that are like closer to zero are the ones you want to take out first. So the negatives don't count. Yeah, right. So, so did the sort part work? Sure. So choose all this, and then data sort, data tab sort, and then there should be like column sort by, and just choose tstat. Yeah. Yeah. Okay. All right. So now, which variable has the tstat that's closest to zero in absolute value? This one, right? Okay. So let's take out this one, days on market, and let's run it again. Okay. And again, this is a little bit tedious, but it'll help you understand the process. So basically, what you want to do is go back to housing prices, delete, just to make it easier for selection. You can just it's this one, right? Days on market. If you just choose the J column back in the housing price data, and just under Home tab, just hit the delete button, and it just takes it away. Okay. And then let's run the model again with one less X variable. Okay.
Did it change anything other than that?
Yeah, it will change. Yeah, because you'll notice at the end that it looks like only three variables are significant,
Yeah.
but that's not the case if you take things out because they're getting mixed in the effect. Yeah,
That's what I was getting.
it will change it. Yeah.
But we just,
Yes. So now you just have beds, baths, square feet, miles to resort, miles to base, acres, cars, and years old. Okay. And then you can like I'm just gonna label this first tab like I don't know regression one, but you don't need to include all these outputs in your homework. I'm just kind of documenting. So let's run again. So without that variable, let's do data, data analysis, regression. Okay. Y, the Y range should be the same, and the X range, if you just change it from J to I, right there, it'll get the right range. So Y range is the same, A1 to A46, and X range is now B1 to I46. Yeah? Nothing else changes, and hit OK. So now we should get the results for the new model, and then we're going to take out another one based on the lowest t-stat. Okay. So did it work? Oh, sorry. There you go. Yeah. Okay. I'm not going to bother with the formatting every time because, but when I get to the final one. So why don't we sort this stuff again? And I'm going to call this reg2. Oops. Okay. Let's choose A16 to I25 and do data sort sort by tstat. Okay. So now we would take out um, looks like this one, right? Years old. Well, they don't count because, but you still want the smallest absolute value to take out.
Well,
Isn't this one's smaller, right? Closer to 0? Yeah. Yeah. So yeah, I think that one's smaller, right? Yeah, okay. Yeah, we could also sort by p-value, but I haven't really introduced that yet, so it's not. Yeah. Okay. But I can double check it there. So just to if you were to double check your analysis, the lowest t-stat in absolute value should also have the highest p-value. So you can see that that's kind of the case, but let's not go there yet. Okay. So now we're going to take out years old, right? Because that's the lowest one now in absolute value t-stat. And then we're going to run it again. Okay. So let's go back to housing prices, take out years old, just click on the I column, delete, home tab, delete. Let's make sure these guys don't have any questions. Okay, then let's do it again. All right. And we're going to do this until we get to the model that has all significant variables. And then we have one more thing to do in the next part, which is to make sure none of the variables are correlated.
would you say pink cloud, right?
Probably, yeah. Okay, so I'll do it again.
Pink cloud, right?
Data analysis, regression. This is now H, A1 to A46 and B1 to H46. Okay,
Do H,
yeah, okay. Reg, it really, as long as we get to the same one, it doesn't really matter how you get there, but let's do it again. Sort these, or I'll make it bigger for you. Sort these by tstat. Now we're going to take out, looks like cars, right? Is that what we got? Yeah, cars, concur. I don't remember.
yeah. The first one was DOM. Second one was
Years old? Yeah, then cars. Uh, yeah, okay, so this time cars go. So then we take out cars again, delete, and run it again. We're getting there. So really, as long as you have this, as long as you don't delete the variables that we need, it's not going to make a difference. I just want to illustrate the process. Um, but don't delete one of the important ones.
that are super low. Get to the higher, like the ones that are like point.
Probably not, but it's likely that this one flips.
Yeah, that one flipped.
Um, but no,
But I didn't like the first line 2 years old.
yeah,
I still have years old.
No, probably likely that, um, I mean, there is a chance that like one of these variables would be captured across the other ones. So yeah, there's a chance that like not just square feet is significant. I know from doing this before that it's not going to be, but it illustrates the process if you do it like this. So why don't we take out cars? We took out cars, and then run it again. Okay, now it's B1 to G46, A1 to A46, B1 to G46. Okay, this is rig 4. Okay, let's look at our T-stats. Okay, now we're going to take out beds. Beds, right? Because it's beds is lower in small in absolute. Or that one's 0.9 and this one's 0.4, right? Beds, yeah. And so also notice that when you take, like, if I take out beds, you would think that would make a difference in a housing price, but it looks like Bass are explaining that size variable better. So instead of using beds and Bass, which are kind of the same thing in size-wise, it looks like we're going to use Bass and assume that if there's more bathrooms, there's a good chance that if you have 10 bathrooms, you have more bedrooms, right? So let's take out beds. Where's beds? First, delete the B column. Okay, we're getting there. I think there's, at the end, there should be 4 variables, so it looks like we're almost beds, yeah. All right, run it again without beds. Change our X range to F, B1 to F46. Everything else is the same and hit OK. Here's reg 5. All right, now we're taking out, oh, we got to sort first. Miles to resort, right? Yeah, miles to resort. Okay. And it looks like you definitely wouldn't want to have miles to base and miles to resort because they're pretty much the same thing. So let's take out miles to resort. And then maybe this will be the last round. Let's see. Miles to resort. Delete. All right, now let's run it with price as beds, square feet, miles to base, and acres. Okay, look at that. They're all significant. So if we get to the same conclusion, we should get to a part where I'm just looking at the T-stats for now. We have Bass, square feet, miles to base, and acres. And the T-stats are 3.4, 2.26, negative 4.86, and 3.49-ish. So do we get to that conclusion? And so now if when we mess with things around, or we took out the wrong things, we see that we get 4 clearly significant variables. Um, and we could look at the t-table, but we know that everything over 2 is going to be significant, so we can assume that any t-stat bigger than 2 is going to be 95% significant. Okay, so this is the output for part A you want to include?
Did you change the data on the big
Oh, no, did I change what?
change the what do you
The
call it?
numbers?
Number.
Oh, I'll do that. So let's do that. Here, let me call this, I'll call this uh, part A from the homework because it's like the part A part. And then if we want to do home tab, format format cells, numbered two decimals in the comma. There we go. And then yeah. And then if you, I'm gonna just do so I can see everything. You can also do like format auto fit column width, which will make it so you can see all the. Okay, so just double check that you got this, this similar result I did. What? Pause. Okay, yeah.
I got it, finally. My answer is right.
It's all the numbers are the same? Yeah. Well, you have some idea, you wouldn't have got it,
Yeah, everything's right.
right?
It's just that I just did the way you showed us, like, so change, I think, from lower to bigger,
Yeah. Hmm.
so I went.
Yeah, that works. Okay. Everybody good on the in the WebEx verse? Okay. Got it? Yeah? Everybody got it?
I like to leave the wrong one, and I just opened it because I did so.
Yeah.
I get out of it,
Yeah.
I can leave it wrong order.
Yeah. Oh, you could, yeah, you can do that too.
Yeah, yeah, but you can't bring it back.
You can always open up a new data set.
Open Excel again, so
Yeah. Yeah, that's probably the more practical way to do it. I just wanted to simplify it, but yeah,
yeah, I like it. Some things like not get written. That's what.
it's just easier to select it when they're all next to each other. Yeah,
Yeah, I'm a new learner, so I need.
Especially when you're dealing with lines of data like that.
yeah.
But this is that now we're in the version.
Well, well, this is for, so why don't we put this, this is gonna go, reduce the variables that are not significant and include a screen cap of this part. So part A is just to include this here. So if you want to just select it and like copy it, Control C, and you can probably, oops, could probably, I don't, sometimes if you paste it, it does like a weird, I'll do that. If you paste it as a picture, it's usually better. Like Home tab, paste as picture, then you can kind of see the results there. So there's your reduced model. That's part A. Okay. Why don't we save this?
Better turn this house like.
Okay. Now, part B, um, which is new, is to eliminate variables if multicollinearity is an issue, and that means if there's a correlation amongst the remaining x variables that's too high, then you might need to take one out. So, for example, if um, square feet and Bass are kind of capturing the same thing, you're only going to want to keep one because the effect is getting clouded by both. So let me show you a little video on multicollinearity. Multicollinearity, and then we'll go to step B, or part B.
You're making that off the house.
Um,
See that white box on the side? Control thing? To your right. That controls your, the little shelf to your right.
what? The white box?
There's that little white Cisco screen on the.
Yeah.
That thing is what controls the phone, I think.
Oh,
Our
I see.
speaker.
Oh, I see. Okay.
Yeah, because we couldn't hear anybody in the class earlier.
Oh, okay. I got it. All right. But sorry, what was your question?
I'm sure the video was like, but I'm just saying, like the multicolored area. Are you basing that off the coefficient value?
No, I'm basing it off the correlation, which we have to get.
Okay.
Like if these variables are correlated with each other. Yeah. Never got there.
Hello and welcome. In this video, I'll explain to you what multicollinearity is and how you can check it online. And we get started right now. So the first question is, what is multicollinearity? Multicollinearity is that two or more independent variables are strongly related with one another. We're talking about multicollinearity. Individual variables not be clearly separate. Let's look at the regression equation again. We have the regression variable here, each variable with the respective coefficient. If there is a high correlation between x1 and x2, if these two variables are almost equal, then it is quite difficult to determine p1 and p2. If both variables the regression model does not know how to determine P1 and P2. This means that the regression model becomes unstable. If you now want to use the regression model for a prediction, it does not matter if there is multicollinearity. The prediction you are interested in how good the prediction is, but you're not interested in how big the influence of the respective used to measure the influence of the independent variable on the percentage must not be multicollinearity, and if it is, coefficient cannot be interpreted meaningfully. So the next question is, how can we now diagnose multicollinearity? If we look at the regression equation again, the variable x1, x2, and up1 to the variable k. We now want to know if x1 is quite identical to any other variable or a combination of other. In order to do this, we simply set up a regression. In this new regression model, we take x1 as the new dependent variable. If we now can predict one very well from the other independent variable, we don't need x1 anymore because we can use the other variables instead. We would now use both variables. We could see that the regression model gets very unstable. In mathematics, we say that the equation is over the curve. We would now look for all other variables. So we estimate now x2 by using the other variable, and we estimate xk by the other variable. In this case, we have a new regression. For each of these regression models, we calculate the tolerance and the variance inflation. The tolerance is obtained by taking 1 minus r squared, which is the coefficient of determination or the variance explanation. The variance inflation factor is 1 divided by 1 minus the coefficient of determination. Multicollinearity exists if the tolerance is smaller than 0.1. If we look at the variance inflation factor, it could be multicollinearity if the variance inflation factor is larger than. And now I will show you how you can easily check the requirements online. math and click on the statistics calculator. If you want to use your own data, click on Clear Table. I will use the example. If you
Okay, so,
Yes, I mean, it's not.
well, this is a, I mean, let me show you what the,
Wait, what does it mean if you understand if you get find X one, then you don't define X one, but can you show me the number of understand?
yeah, so, well, that's what we're gonna do in our homework, but, so you don't want, like, you don't want x1 to be a function of the other x's. That's the only thing. So, like, in our case, um, we're left with Bass, square feet, miles to base, and acres. And what we don't want is there to be a function between, we don't want Bass to be a function of these two, or we don't want acres to be a function of these two. We don't want them to have correlations with each other, or not high enough. Because if they do, then the interpretation of the coefficients would be inaccurate because some of the power is going to one and some is going to the other, and you don't really know which is the full effect. So what you want is variables that predict y, but don't predict each other. That's what we're doing. So the short answer is you don't want these variables to have a high correlation with each other. Right. Like the clear one was baths and bedrooms. Those are pretty much the same thing, and putting them both in will not give you the proper interpretation. So you got to get rid of one of them. And in this case, I'm not sure if I can't remember which one of these variables is correlated, but if I had to guess, it's probably baths and square feet, um, because they're both predicting the size of the house. This is probably doing its own thing because it's distance, and this is really the size of the lot, which is a different thing as well. These are both the size of the actual house, right? Kind of. So what we're going to do next is diagnose if there's a correlation amongst the x variables, and if so, then we're going to have to take one of them out and leave the other one in. Yeah, sure.
I'm looking at the analysis. So it'd be like one bathroom, $59,000, right? Based off if that's how you analyze it.
No, that's not, that's, so you don't want to look at the coefficients at all. Actually, you don't want to look at any of this stuff. You just, right, that's the thing, is this is all telling us how these variables affect price. None of these are telling us how these variables affect each other. What you could do is get some other measures like that VIF, but we're going to just stick with just basic correlation. If you recall from like the first day, we just looked at correlations, which we were looking for a correlation between y and x, but now we're not looking for a correlation between x's. So we'll generate a little correlation matrix and see what we can do for this part, right? So I think we got the gist of this, right? Okay. Now, one thing that, so I guess what I should have done to start with, I mean, is what I normally would have done, is instead of delete all the variables, usually I would have like one tab that has all the variables and then then like modify the other one. So that's what I recommend doing, based on, that's good. That's a good point, that you don't want to just start deleting variables. But what I would recommend is, for example, if you had like a separate tab that was just something like master data, and all these variables were there. Okay, and so then you could have, I usually keep this one. So maybe your master data was the first one, and then the ones you were modifying, let's say this is like, uh, I don't know, working data. Okay, and then if you save it, you can see this is what you started with. and then this is the data you reduced. But then that way you have just a list which doesn't get modified, and then another list which you reduce. So that's what I guess that's what I recommend. Is not for this assignment, it doesn't matter, but if you're doing a big analysis, keep one sheet that just has all the variables not modified, and then keep another sheet where you're modifying, and then you can kind of keep track of your regressions. Okay. So we are, um, okay, so we're on the working set because we're working with these four. So we can do, examine the correlations between these four by looking at a correlation matrix. So if you do, make sure you're on this tab, the one with the just price, BAS, square feet, miles to base, and acres. And then do data, data analysis, and there should be correlation.
But we did that like this, no, right?
We did?
Couple of days, no?
No, we did regression, right?
Oh, you did.
Yeah, so correlation, okay. And then if you choose all these variables, so B1 to E46, and then make sure you choose labels in first row.
So
Yep,
the fun, the Y or
not the Y,
only the X?
all the X's, yeah. So B1 to E46 and labels in first row is checked. And then hit the OK button. Okay, now
Yeah, what you do is
I didn't touch that. Oh, yeah, labels. Sorry, yeah, labels. Yeah, and then you should get something like this. Okay, and let's call this all these tabs now. We can call this correlations or CORR. And what you'll see here, if I can reduce this again, so if I just do the labels again, home tab, format cells, numbered, 2 decimals and a comma. Okay, so this is BAS, this is square feet, this is miles to base, this is acres. And so obviously like BAS has a 1 means 100% correlation, 0 means no correlation. So the variables that are looking at each other are the same, right? So BAS and BAS predict BAS. But what you're looking for is a high correlation amongst the other ones. Uh, and the negative doesn't matter, but usually like, so these ones you can ignore because they're just ones. But if you look at BAS and square feet, that's pretty high. So let's make a note of that one. Miles to base and BAS. And usually like if it's under, I mean, definitely if it's under 0.5, you don't have to worry about it. So there's not much of a correlation between miles to base and BAS. There's not much of a correlation between square feet and miles to base. There's not much of a correlation between BAS and acres. There's not much of a correlation between square feet and acres, and there's not much of a correlation between miles to base and acres. The only concern is this one. So is it clear why that's the concern? So these are the correlation coefficients. And it's close. Yeah, right. Okay. Yeah. So we have two ways to proceed here. So we first, why don't we just look at a scatter plot and see if there is a relay correlation, and if there is, we should probably take one out. If it doesn't look too bad, we can just leave it. But why don't we go back to part working data, and why don't we make a graph? You can select BAS and square feet at the same time, kind of, oh, they're next to each other. So if you choose B1 to C46, or the entire B and C column for BAS and square feet, and then insert tab, the little scatter plot chart, and then scatter, So it looks like they're pretty correlated, right? It looks like it's pretty clear that when um, there's more bass, the square footage also increases. And like if you were to put like a trend line to it, like we did back in the past, and do chart design, add chart element, trend line, linear. So it's not it's pretty evident there's a correlation. So given that the correlation coefficient is high, pretty high, and there appears to be a positive relationship, we'd probably want to take one of those variables out. Yeah? Okay. So which one would we take out? Um, Probably, so we're looking at mass versus square feet. This one or this one? Probably take out square feet because the lower t-stat, right? And that's the lowest t-stat of all anyways. Um, yeah, yeah, yeah. So keep an eye on this model because there's two ways of looking at it. So um, let's run the model one more time without square feet. Yeah, let's do that. Okay, so back to working data. Um, I'm going to delete this graph for now because, and then we're taking out square feet, right? What I said? Yeah, take out square feet. I'll delete it, but remember I have my master data in case I need it later. Okay, now let's run it again. Data, data analysis, regression, okay. A1 to A46, and then B1 to D46. And let's hit okay. Okay, let's call this part B. Okay. Um, let's see what we got. So now we have uh, no variables that are correlated and pretty high significance for all. Um, but the thing to notice, I'll do the formatting first. Okay, so what part A had a r squared of 0.8, and this one had a r squared. So the here's the trade-off. So this one better explains why. This one has a more accurate interpretation of the x variables. So if you wanted to focus on interpreting what these things mean, you'd want to look at this one. If you want just the best model to explain why, just look at the r squared. That's the trade-off, right? But here's our reduced from A, and here's our reduced from B, which now only has Bass, miles to base, and acres. So this part would, so we eliminate all the multicollinearity, include a screen cap with the significant variables that don't have a correlation, which would be this one. Okay, just Bass, miles to base, and acres. So this goes in for part B, right? We took out uh, square feet. So we'll put this one for part B. Okay, so you can see in your answer sheet, you've got the first one, which has, for part A, Bass square feet miles to base acres, and the second one because just has Bass miles to base in acres because we noticed a pretty high correlation between Bass and square feet. But again, notice that this one predicts Y a little bit better than this one. But the interpretation of these Bass and square feet variables would good. I mean, good thing to note is um, look at the coefficient change from Bass here to Bass here. It went from 59 to 88. So clearly this was not the right interpretation with square feet in it. Um, and it jumped from, one bath increases the price by 59,000 to one bath increases the price by almost 90,000. So big change. And look at the other ones didn't change too much because there was no correlation. But just, I think that's, take a note of how the bath's coefficient went from 59 to 88, right? And I bet if you took, well, I know if you took Bass out and left square feet, then this would change as well. So if you're interested specifically in square footage predicting price, take out the Bass variable and then look at the square footage. Okay, yeah,
The copy and paste of there is 7.9. Yeah, I can keep on doing the way it showed last time.
yeah.
Was
Oh, okay, gotcha. Yeah, so so in your answer sheet, double check this one and then this one, I guess. Okay, so do we get, I think the first part's it's a little more tedious, but it's a little more clear. The second part takes some, uh, you know, analysis to look at the correlation. But does everyone understand the part B concept? How you,
can you play a little bit at B?
Hmm. Yeah,
So you took it out the square feet down for what? For
so originally we had these four, Bass,
right,
square feet, miles to base and
right,
acres, right? And
And
so the second diagnosis was to look at if any of these variables are correlated with each other.
right, and this square feet was the path square feet was 2.2 feet low. So
Yeah, I took, after we determined that there was a correlation between Bass and square feet.
oh, from the correlation.
Yeah, yeah, that's why.
That's why.
Yeah,
So
from there, because we looked at the correlation coefficient. Yeah, yeah, yeah.
But think of miles,
Well, because that one doesn't have a correlation with anything. See, yeah, these ones are just them on each other, so ignore those ones.
okay.
See what I mean? Like that's just square feet and square feet. So what we're looking at is these ones, and this is the correlation between Bass and square feet, Bass and miles to base, Bass and acres, and all these other ones have a pretty low correlation, if any, right? Like if the highest it can get is one, or like one is 100% correlation and -1 is 100% negative correlation. This is only like 0.5, 0.3, 0.15, 0.26, zero point 0.9. This is almost zero point 0.8. And then we looked at the graph, and it looked pretty clear that when bats go up, square feet go up, right?
Oh,
Yeah.
I mean, 80%.
80% of correlation.
Yeah.
Okay, and then when we looked at part A again, we took out square feet because it had a lower t-stat. Because we were comparing these two. Those are the two that had a correlation, and the one we took out was the lower significance. You'd probably be okay taking out either one, but You got to make it as, yeah. Okay. Uh, any questions from the remote audience?
Knock, knock. Can anyone hear?
All right. Now we got a couple more parts for this one, but that's the main. The rest of it, you've already defined the variables, and this one you kind of just plug into uh, the model.
Okay, I didn't have it, huh?
Well, you're getting farther along in your analysis toolkit, I guess. Whatever you call- Okay, ready for part C? Yeah? Okay. Yeah, now define and interpret the coefficients in the reduced model. So let's just stick with this one because there's less. Okay, so we see our coefficients they're listed right here, so we don't have to go far. So I'll just do each one individually. Let's do a little like. Okay, so the Bath's coefficient is 88.95. So this is pretty similar to what we did before. So how would you interpret that? Or actually, define and interpret the coefficients because I don't want to get confused. So let's do that first. Okay, so y equals, I even forgot what y is. It's price and Mac, price in thousands, right? Is that what I said? Yeah. So y is the price of home, and this is thousands of dollars. Okay. X1 equals baths. So this is just number of baths, number of bathrooms. X2 is miles to base, and that's in miles. Pretty self-explanatory. And then X3 is acres, just in total acres, right? Okay. So okay. So how do we define? How do we interpret the coefficient for Bass? Yeah, that's you can just come up here and type that. If the number of Bass increases by one, we'd expect the average home to increase by $88,950. Okay, exactly. So then miles to base would be 3.51. So that would be if we're another mile away, the value goes down by this. in thousands, right? So basically, you can write it either way you want, is the price of the home decreases by $3,510. Whoops. Each, let's say, with each additional mile the home is from the base. Okay, the price of the home decreases by 3,510 with each additional mile the home is from the base, right? So the farther each mile away, you lose this much in value. Okay, and then finally, okay, let's put this one up here. So, acres. All right, so basically each acre increases the home by 4,940, right? $4,940 with each additional acre on the home lot. Okay, that's all pretty new, pretty standard, right? Okay, then last part is you could use this model to predict what the price of the home would be if you get some parameters. So like another reason you want to have a model like this is because if you're like, okay, I want a home that's 2,000 square feet with two backs, this much to the resort, and sits on 1 acre. Okay, so if you want to predict that, you would use this equation and plug in these values and then calculate the result of the price. So for example, let's, we could do this like this. So why don't we write out our equation with these coefficients and then just plug in the values, yeah? So I'll make it a little smaller just for a second, and then I'll go back. So I'm trying to see those things, yes.
And since it has square feet.
We're using the first one, yeah. I'll make this bigger, sorry. I have to be able to see these real quick. So price equals 197.15 plus 59.21 times BAS plus 0.05 times square feet minus 3.80 times miles to base, and then plus 5.01 times acres. Okay, price is 197. Okay, so now. So there's our general equation, and I got that from this. I just plugged in the coefficients, right? So this is the effect of BAS, square feet, miles to base, into acres. So 197.15 is the intercept. The effect of Bass on price is 59.21. The effect of square feet on price is 0.05. The effect of miles to base on price is negative 3.80. And the effect of acres is 5.01. Okay. And I kept in the square feet one because this one asked to put that in, right? So now what we're gonna do is plug in 2,000 for the year, 2 for here, 15 for here, and then 1 for here, right? So we can expect the price of the home to be roughly 197.15 plus 59.21 times 2 bass plus 0.05 times 2,000 minus 3.80 times 15, and then plus 5.01 times 1. Okay, 197 plus 59.21 times 2,000 square feet.
Good question.
Yeah.
But that's at miles. On the master spreadsheet, there is a miles to base.
Oh, yeah. So this is, I guess I should say miles to base, right? Base. Miles to base. Okay. So 197 plus 59.21 times 2 bass plus 0.05 times 2,000 square feet minus 3.80 times 15 miles away plus 5.01 times 1. So that should give us the estimated price of the house for these things, which is, okay. 363.58. Yeah, is that what we got? Okay, so we'd expect the price of the house with these features to be about this price. What? Oh, sorry. Yeah.
That'd be awesome.
Yeah, 363, 580,000. Thank you. Three. I mean, these prices are already way lower than they would be now. Yeah. Or maybe it's in like North Dakota or something. Okay. Yeah. And then that's the full question. That's number one. So, so basically we ran the whole model and we took out variables that were not significant. Then we looked for correlations and took out X variables that had a correlation, if any. Interpreted the coefficients, we've done that before, and then used the equation we got to predict the price that the model would estimate. Okay, so should we take a quick break? Okay. Oh, oh yeah, go ahead. I'll leave it there and then
No, it's like,
yeah, pretty much. Yes. Well, there's even something that'll say it's spelled like stepwise. You just say like two, but that's all.
that's like a good way to like understand.
Yeah. All right, we'll take a. We're gonna take a break until 2:30. Um, that no, that took longer than more out.
The long, yeah.
Oh, steps, right?
I mean, it's not hard once you know it. But
Right.
no, can you put a bit up on the key part, the mid spell?
Deeper?
Yeah.
Then, oh, sure, yeah. Roll up.
Yeah. Yeah.
There you go. Type of. Yeah.
Anything else? Do you know when the last the yeah. Next week. is only after that, right?
I think that's it.
That's it? Okay.
Yeah. Got it all?
Yeah.
Okay.
So all the homework is similar to this, or?
Yeah, it's similar. Well, the third one is a little bit different, but only because there's another binary variable with three categories.
I was going to define, like, at least like one and zero, one with like those, or one with like yes, one with no.
Yeah.
So and that's how what we pretty much need the program. Having said that, I need to understand.
Well, that's why we're.
Oh, okay. I mean, theoretically I understood, okay, one and zero, and then
It's just an easy way to categorize. Like if I want to categorize population being Republican Democrat, but all the like Democrats are one, then by default all the Republicans are two. If I categorize one, I categorize both. Right?
okay, so in that case also, for example, if you say all Republicans are zero, all Democrats are one, how about if the other one?
That's the different categorize. That would be okay.
So it has to go like two.
No, we could like Republican, Democrat, Independent. And then Republicans one, other two are zero. Democrats one, the other two are zero. All zero. Then yeah, we're gonna have those multiple.
So what is the use for? I mean, when you go to work, let's say when you work.
Let's see if there's like for this one, there's like a file, another file for Java, and there's a category for hybrids. If you like to see if your car is automatically a little bit hybrid or not. And you should be like,
I was trying to start, but it won't let you have two questions.
oh yeah.
I was starting, I moved it to the right side. Moving in the direction. So I knew that was like, I'm like,
One, and it's not like zero, and then it's like. Yeah, you may want to consider it like kind of a fundamental breaker for people that don't touch themselves every day.
Yeah.
Cause that's what I'm like, I like me, for me, it's like, it's easy, cause like, you're like, okay, you just do this, do that. Like, I already know how to operate stuff, but for like Brian and people that don't touch it every day.
But,
Like, even like a tips and tricks or,
Yeah. Oh, okay.
so just like, yeah, it's like a thing.
yeah, just something,
Okay.
yeah.
When I started my undergraduate, I was gonna do it.
You
Two,
know,
like two flat, like Excel box back to back. So when I was looking at this. Bits, but like,
I mean, I was hating it. I actually hated SQL, Excel. It's not that I have done that. I did it. I mean, even SQL, I did it. I know it, but I don't much. I mean, I understand. If you ask me to do it, I can do SQL, and I can do Excel also. But if I don't practice that, get really what I don't know.
Yeah. Well, you like it now, right?
I mean, now I can just understand. Once you know, then it's easy. Okay, I understand. This is why you get the comma. This is how you get regression.
Yeah.
So it's easier,
step later, helpful. It'll be anything like tracking any type of data.
Yeah.
Rather than it taught me how to change the numbers from big to small, now I can take the numbers.
Oh, yeah. Font size?
Yeah, from the size, and then the arrow,
The subscript.
Oh, yeah.
and then you showed us the arrow. It's pretty cool, huh? I can do the arrow. So from those things I end up taking before. So people say they know a lot of words, but that's so easy to learn. You still don't know.
Okay. Let's see. Okay, so why don't we do a little more, and then if we don't finish this one, we can finish it next time. Because this is not due for a couple weeks, right? Yeah, so not due to. You want to? Well, it's only.
See, everyone in the class is thinking. See, no one is responding.
Well, they might. No, I'm not gonna check.
Hello, hello.
That's all right. They can.
They can.
I don't think so. Yeah.
No, they can. When I was on. You guys really.
Okay. So why don't we do the fuel efficiency one? And all right. So, but you're right. We got to change that one first. So let's use data set fuel efficiency. So this housing prices is. Yeah. No, what makes it easy? It'll make it easy to categorize. So we can save this. Uh, oh, actually, I have a video real quick.
Whenever you open up the app, you click. In the background. And then it automatically.
All right. Yeah, I'm gonna play one more video actually on binary variables since we're about to talk about these. So let's see about this guy here. Uh, what's that? Oh yeah, that's I know, right? It seems like it. Yeah, yeah. Okay. Hopefully that was helpful and not more confusing, but we'll see. What? Okay. Also, if you noted, I graded your first assignment, so it's out of 7. If you got a 7, you got a full credit. Just uh, okay. Then let's open up fuel efficiency 2011. Okay, so right, we've got 200 variables, 200 observations, make and models in 2011, and we have different MPG estimates for those. And we're going to try to predict miles per gallon using these other variables. So for this one, uh, we'll run it with miles per gallon as the dependent variable, and all the other variables as x variables. So good thing to know is before we do that, we have to fix this one because Excel won't recognize this concept. It will recognize ones and zeros. So for the other things, let's go through those first. So this is the y variable, miles per gallon. Curb weight is the weight of the car. So you would think likely a heavier car would get less fuel economy. You'd think bigger engines would get fuel economy because that usually means like faster car. Same with cylinders, horsepower. I'm not sure about length. Maybe that decreases fuel economy. Um, Seating capacity, torque, wheelbase, is the car a hybrid, and then the price of the car. So can we use these things to predict the fuel economy of these cars? Probably, or else there wouldn't be a data set. Okay, so before I make the same mistake as last time, I'm going to open up a separate tab, and I'm going to call this working data. And then we can leave everything in the original data set, copy and paste it to the other, and then modify that. So leave all this the original data set here just in case you delete something or have to go back. But the shortcut to copy and paste the whole section is if you just click on like the A1 and hit Control A, like Control A is in Alfred, and then Control C will copy, and you go to your other tab and just Control V is paste. So Control A selects all, Control C copies all, Control V paste. Then let's just leave this original data set alone, and let's work with the working data, right? Didn't work?
P, right?
Control C and Control V is in Virginia. Worked?
Yes.
Just, I know.
Yeah.
Okay, so what we need to do is reclassify the hybrid section as ones and zeros. Now, in practice, it's probably easier just to, or it's probably better to write a formula, but because there's only 4 or 5 of them, we can just do it manually, probably easier. So why don't we uh, hit the L column and hit under Home tab, Insert button up here. Just insert a row, a column, and let's call column L hybrid, HYBRD.
Okay, so cell
Uh, if you click on the L column, I mean the M column or whatever it was, and just hit L. Well, it was. Oh, was it L? Yeah, it was L. Yeah.
okay.
So here, I'll do it again. So click on the L column, and then under Home tab, hit the Insert button, and it should insert a column. Yeah. Okay. Then the new L column, let's call this hybrid. Okay. And then all we're going to do is classify the hybrids as ones and the non-hybrids as zeros. Okay. So easiest thing to do probably is just start with all the non-hybrids because there's more of them. So just if you just type in a 0 in L2 and then click on L2, and if you just double click the bottom right corner, like, oh yeah, well I was gonna do all zeros first, and then non-hybrids will be ones. But I was gonna autofill zeros and then switch it back. Well, you're right. Yeah, this one should be a one.
that would probably
Throw off the what?
the data.
Yeah, exactly. Yeah, okay. So, right, it's going to be a 1, correct.
5.0.
We're going to, no, let's, yes,
There's that one outlier.
yeah.
It was one.
Yeah, 'cause all-
Yeah,
What were you saying about the, what were you saying about like the formula? Is there like a thing that was like every other one, like hybrid, not hybrid?
yeah, you can just say like if this, then put in 0. If not,
Oh, like, there's like a function.
there's just an if function. Yeah,
Oh, yeah, I was wondering. I would imagine. Like, oh, within their mix, that's really like-
yeah, it's something like if this is this, then put in 0. Otherwise,
Oh, I got it.
you got it?
Thank you.
Okay, thank you. Okay, so what I was going to do is just autofill the zeros and then change the hybrids to 1. So if you put a 0 here and double click the bottom right corner, it should just put a bunch of zeros in. Okay, and then because there's so few of them, I was just going to change the hybrids to 1s. Wait, this one was a non-hybrid. Oh, yeah. So,
That's what I was asking.
oh, yeah, yeah. Hy- Hybrids are 1s. So hybrids 1, hybrids 1, hybrids 1, hybrid 1, hybrids 1, and then the rest are zeros. Okay, so I think that's all of them, right? Okay, you got that, Noble?
Yeah.
Okay. Okay, so non-hybrid 0, hybrids are 1, non-hybrids are 0. Okay. Just double checking. Okay. Now because we've already got our master data set, we can delete this K column, right? So click on the K column and Home tab, delete. And now we just have 1s and 0s. So now the model should be able to run with this as a binary variable, and everything else should be okay. Okay, so now let's run a regression where this is the y variable as a function of curb weight, engine size, cylinders, horsepower, overall length, max seating capacity, torque, wheelbase, hybrid, which is now 1s and 0s,
Which one is the Y?
MPG highway. This one. Right?
Is there a quick way to get this? Quick way,
Quick way to what?
because actor. Mhm. Okay. Okay.
Well, wait. Oh, he's jumping ahead. Okay. All right. So we're gonna. You probably already started to. Anyways, right? Yeah. Okay. So we're gonna run a model. Yes. With this is the y variable, and then all the other ones are x's. And then make sure you leave this one out because it's just the type of car. So don't include this. All right. So data analysis, regression. Okay. Y range is B1 to B201, and X range is C1 to L201. And then labels. So the first round is Y range is B1 to B201, and X range is C1 to L201, and labels are checked. And hit OK. You got a lot of things here. Okay. So we want to start eliminating things that are not significant, um, one at a time again. Didn't work. The output. Okay, so we'd get all these variables as a result, and then we're going to eliminate the one by one again by significance. All right, so we could do what we did last time, which is choose this coefficient uh, output range, sort it by t-stat, and take out the ones that are closest to zero in absolute value, which looks like this one's like almost basically zero. Overall length goes first. Yeah, that one didn't make any sense anyways. Okay, and then we just, so everyone's okay on this process here, reducing. Okay, well so I'm going to take out overall length and run it again. And again, I'm going to delete it, but I have it in the master data set here.
Why do we know?
Where am I? I'm going to take out overall length because it has the lowest t-stat.
Oh,
Yeah,
but 0.01.
point zeros. Yeah, right. Okay, so back to working data. Take out overall length. Delete. Run it again. And really, all you have to do is change the one letter, right? So new Y range is B1 to B201 and C1, B1 to B201 and C1 to K201. Okay. Here's round two. Okay. Let's sort our output again by t-stat. Let's take out horsepower. Take out horsepower. Um, Back to working data. Take out horsepower. Run it again. Change the range from C1 to J201. Okay. Here's reg 3. Okay. Um, oops. Sort it again. Okay, we're getting there. We're going to take out fork. Yeah.
I think
Okay, yeah.
the video,
Well, I'll post the video, but
yeah.
we're doing the same thing we did last time. Okay, take out torque. Run it again. Change the range to C1 to I101, I201. Okay. Check it again. Okay. Maybe at least, maybe this is, so MSRP goes out. That one didn't make any sense. Okay, MSRP. Take MSRP out. Run it again.
I have a question. So
Uh,
if you are going to each and every one to go up, how far do you go?
until they're all significant. Yeah, that's okay. And so you go until all the variables are significant. The t-stats like bigger than two, two, two. Yeah. So see how in this round, this one's 10, this one's 5, these two are questionable, and this one's 3, 5. So basically, like the ones that are not
Really?
bigger than 2 in absolute value, they don't explain MSRP or MBG.
Messed up over here.
Yeah, right. Yeah. Okay, so we took out MSRP, I think. And I'm going to run it again. With the C1 to H201. Okay, now I think we made it. All right, so this is it. All the t-stats are -10, 5, 3, 5, 2, and 8. So we have, let's see if I can make this. Okay, so I'll call this part A. Oops. Okay, and our reduced model for part A has curb weight, engine size, cylinders, max seating capacity, wheelbase, and hybrid. Yeah, that's what you got, Chris?
I ended up the big for way.
All right, yeah, nice. Okay. That what you got? Oh, it doesn't matter. Yeah, the order doesn't matter. Cool. Oh yeah, I didn't sort the last
Sorted and then unsorted.
one. Yeah, I
Hopefully
could.
that helped.
Yeah, that's
Get it like
right. I know. That's what I. Yeah, I guess I could sort this one just to be.
I did, but then I unsorted for the picture.
Oh, because of the intercept part.
Yeah,
Yeah. Okay. So this would be part A. We would take a screen cap of this. Control C isn't cat, right? Copy. Oops. Where are we? Did this, and then Control V is in Virginia. Well, not that. In this case, you'd want to do home, paste, and you want to choose picture. Okay. Now we get to check for correlation, right?
So after you do that, then you check correlation for what?
We want to check now to see if any of these x variables have a correlation with each other, right? Because if they do, then the interpretation of the coefficient is misleading because both of them explain the same effect.
Is there something we like, is there like a percentage which you're like looking to eliminate for that correlation? Like, is there,
Oh yeah, so it's around like I don't know 0.75 ish,
yeah, okay, the one that we.
something. Yeah,
I think
0.79. But you got to, I mean, anything over 0.5 first you want to look at, but anything under 0.5 for sure doesn't matter. Okay. Yeah, well, I'll have to look. Okay. All right. So the next part would to be to look at the correlations and see which ones might have a correlation with each other, right? We have time. Okay. Um, Let me save this before I trip on the cord or something. No, I mean that. Yeah, that ruined the whole recording. I know. I know. It's. I know. It's such a one. Let's see. Okay. All right. Now, so we're gonna go back to the working data, and we should have 6 x variables left, right? 1, 2, 3, 4, 5, 6. Okay. Now, the good thing is we don't have to worry about correlation with the binary variables because they're just categorical. So you can leave this one out of the matrix because you can't really have a correlation with a 1 or a 0, right? It's either going to be one or the other. So
if you include it,
I don't know if it work. I'm not sure if it'll do it, but we can try it. It left. Did it work?
well, it ran.
It ran. Okay. Well, we can leave it in. Yeah, let's leave it in then. It just sometimes it gives like an error, but okay. So if I were to select, or let's do, so on working data, data tab, data analysis, uh, correlation. Okay. Then the range is C to H. So C1 to H201. And then labels in first row. And then hit OK. I guess it did work. Oh, Sia has like a. It does have a weird.
I
Anyways,
just don't know. Like,
yeah.
I just like, I didn't. So,
No, I just yeah. I thought it might not work with the because if you try to run it with like this, it won't work. But because it's okay, so let's call this correlations. All right, so let's take a look at what we got here. I'm just gonna reduce the decimals, format cells, numbered 2 decimals, comma. And I'm also gonna make it so we can see the titles, format autofit column width. Okay. So, whoa, we got some potential issues here, right? So now really what we would do, because there's multiple issues, is we would take the highest correlation out and then check it again.
What cylinder?
Yeah, cylinders. Well, let's see. Okay, so this one, remember, don't worry about these ones because they're correlations with each other. Okay, so definitely I'm seeing this one as an issue. Engine size and uh, cylinders. Um, Other potential issues are these ones, but we should definitely, and then this one. So it looks like curb weight has an issue with all these things. But that looks like the highest one, right? 0.93? Yeah. Okay, so why don't we take a look at the graph of engine size and cylinders and see if there's a pretty high correlation, which there probably is. Then if so, um, we should take that one out. We just take one of them out. Okay, so let's do, let's see, engine size and cylinders. So why don't we go back to working data and graph engine size and cylinders by selecting D1 to E201 altogether, and then insert the scatter chart. So it's like a huge correlation, right? So we got to take one of those out. If you were to, like, if I were to put the tread line. So it's clear that when, which one is which? I don't know, but it doesn't really matter. This looks like engine size. So when engine size goes up and vice versa. Okay. So there's a pretty big correlation between engine size and cylinders. So what we'd want to do is look at the results from part A and take one of them out based on significance level. So if we're comparing engine size and cylinders, we'd probably want to take out cylinders, right? Yeah. Okay. Let's make a note there. So we're going to take out, yeah. Okay. So cylinders, or sorry. Okay. Engine size versus cylinders. And we would take out cylinders. Okay. Okay. Let's check the other ones. So if cylinders is out, that doesn't matter anymore. Um, but so that one's pretty low. That one's that one's pretty low. That one's pretty low. Low, 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 low. 0.62 is probably that one's going to be out anyways, engine size. So now we're looking at, um, you know, I'm going to run this thing again because I'm getting confused with let's take out engine size and redo the matrix because if that one's out, it might make it easier. Sorry, take out cylinders. That's what I meant. Thank you. Take out cylinders.
So with this, there were so many, you find the one to eliminate. And then because the other ones are all high, you run it again
Yeah,
without, with the one you're.
the correlations won't change, but it's easier to visualize once you take out the big one. So let's take out, yeah, thank you, cylinders, and let's run another correlation. Okay, so cylinders goes out. Cylinders goes out, and now let's do data analysis correlation. Okay, uh, and we want to do just the C to G column. I hit OK. All right. Let's call this correlation 2. So now it looks like our only issue is these ones over here. So let's make it, we're almost out of time, but home tab, format, format cells, number. So, okay, and then
It doesn't change at all. Like figuring that out.
well, it shouldn't because
Yeah,
their
no,
correlations. Yeah, it shouldn't change it, but it makes it easier. I was getting confused because I got to get this one out of there first. All right, so let's look again. So let me take these ones out of my view. Okay, so not a big deal, not a big deal, not a big deal. So let's look at curb weight, engine size, and curb weight, wheelbase. So possibly if we just take out curb weight, we'd be good. But let's check these ones. Okay, let me, so low, low, low. Yeah, right. Those are the only two over 0.75, right? Okay. Let's look at a graph of curb weight and engine size, and also a graph of curb weight and wheelbase, and see if there's a correlation to deal with. So curb weight, engine size. Just a scatter plot. Oh, gee, yeah, if that's not a correlation, I don't know what is. And then what was the other one? Curb weight and wheelbase. Yeah, curb weight, and so you can make a graph of two non-consecutive rows if you choose one, and then if you hold down Control and use the mouse to select the other, like this. So curb weight and wheelbase selected. That's what I wanted, right? Yes. And then insert, scatter. Not so much on that one, but this one for sure, right? Yeah.
There's a bigger wheelbase.
So let's look back at, so again, we're kind of making some judgment calls, but so curb weight seems to be the issue. If I look at the results for curb weight, I don't know if I want to take that one out because engine size, curb weight, or wheelbase, curb weight. Let's see. So this one's a little bit more, so based on what we've kind of done so far, uh, what do you think we should, what do you think I'm going to recommend we do?
I thought when they should, where's the, above, like that one.
Yeah. So if,
So,
yeah, so if we take out that one, we're still going to have this issue. Um, so what were the correlations? 0.78. I think I would just, we definitely have to take out one of these two to start with. So either engine size or curb weight because of that huge correlation. Um,
When you go like, yeah. So the coefficient of nothing.
no, not at all.
Like the wheelbase. That
But maybe this one's also misleading because this number is a lot bigger than, well, no, not so much. So I think I would definitely take out either engine size or curb weight. Um, and because curb weight's so strong, I think we're gonna have to take out engine size. And then let's look at the other one again. Um, Wheelbase and curb weight. See, that one doesn't look too bad to me, right? The reason the correlations are one thing, but like looking at the graph is another.
Like the size of straight line.
Yeah, because like if I put a trend line on this one, it's a pretty clear upward trend, but this one is pretty flat. You see what I mean? Like, and I'm not sure if like just what I mean is by looking at this is I'm sure that these move together. I'm not sure about this one.
Okay,
It-
yeah, it's a little more.
yeah,
So,
it's almost so I think we'd be okay just taking out engine size and then going from there.
So you don't take the cylinder.
Cylinder's already out. You're taking both out.
Just because the two are under two.
No, so we're taking out. So first of all, we had the biggest issue was engine size and cylinders were correlated. So we had to take out one of those.
Right. So we
So first we're taking out.
yeah, we took out in it.
Then we found that uh, engine size and curb weight are correlated. So we have to take out either curb weight or engine size.
How do you find that?
The,
That it's correlated.
oh, so you look at the correlation matrix.
So that
And
179. So
yeah, and so
that's
like
high.
it's pretty high.
That's why.
Yeah, that's why, right? So because like a if it's one, it's 100% positive correlation, or negative one is, and so closer to zero means no correlation, or really under like if it's under 0.75 either direction, you're probably okay. But even like zero point 0.8 is like this one we found was okay, but it's worth looking at if it's I guess as so what I would say is for this one, I'll make a note in the I'll make a note in the homework here. So eliminate variables of multicollinearity is an issue. So what I'd say is here's what we did. Um, look at the correlation matrix first. Okay. So look at the correlation matrix. So what's happened? Okay, then let's see. Any correlation that are greater than 0.9 in absolute value, then that means for sure multicollinearity, I don't know how to spell that right, is an issue, and one of these x variables needs to be removed. Okay, but the second thing is some things are in between that range. So I'd say that any correlations in absolute value uh, between 0.75 to 0.9, because 0.9 goes out. Um, look look at the scatter plot and um, decide if the correlation is too strong. And then when removing an x variable due to multi-collinearity, remove the one with the lowest t-stat in absolute value. Yeah, and those are kind of the steps that we went through but didn't define. So I think it might help just to define them. Uh, oh, so sorry, we're just about out of time. But so when you're looking for this step, look at the correlation matrix. And then any correlations that are greater than 0.9 in absolute value, that's 100% an issue, and you got to take one of them out. Multicollinearity is an issue, and one of these variables needs to be removed. But if they're in the range which is questionable, which is any correlations between 0.75 and 0.9, take a look at the scatter plot and decide if it looks like a strong correlation. Because remember, one of them clearly looked strong and one didn't. And then when taking one of them out, take the one out with the lowest t-stat in comparison to the other. So that's kind of what we did. We are correct. So first we were comparing engine size and cylinders, right? So for that's step one. So we're taking out either engine size or cylinders. So from that part, we take out um, cylinders. Okay. And then the second issue was looking at curb weight and engine size and curb weight and wheelbase. So looking at those two, it looks like this one doesn't really matter that much, but this one does. And so now we have to take out either engine size or curb weight. And so based on engine size versus curb weight, this one's a 10, this one's a 5, this one goes out. So there's kind of multiple steps there. So when we do this, you can do it at home or we can do it next time. We're going to reduce this to curb weight, seating capacity, wheelbase, and hybrid.
So even though there's another one, wheelbase at 0.78, that's like at this point, you do best guess based off of the data.
So the only one that's left is wheelbase versus curb weight, right?
I think if you delete that one, it's all about weight.
Yeah. But again, this one doesn't look like very much of a correlation. I'm only just looking kind of, first of all, at the numbers, and second of all, at what it looks like. It looks definitely clear that there's a upward correlation here. It's
I have all this kind of diagram. How does it not? What is E?
we'll see how like if you drew a straight line, if you were
Yeah, I can draw a straight line. I see the line. I see that, but then when you become why you don't want the kind of like
well, I think we're looking. So this one. So just look at this. So if I were to label this one, this is engine size versus curb weight. Okay. So this is, sorry, I can't remember which is which. Engine size over here. And this is curb weight. Okay, engine size versus curb weight. Okay, so does it look like, just without looking at the numbers, does it look like that when the curb weight increases, the engine size also increases? Just looking at the graph. Noble?
Yeah.
Yeah, so that's a correlation.
So here's the, I just ran the next regression for part B.
Yeah.
And when you run it, no base, hang out.
Yeah.
Take our engine cost, no base, so then I run now, it's low.
Oh, is it?
It's 1.90 instead of
That's, yeah, it's close enough. Well, I guess that's a, yeah, I guess,
5%.
well, good point. So maybe what we should have done is we took a shortcut. We should have done, once we found the big correlation one, we should have taken that one out and run it again and check for significance. You know what I mean? Like you just did.
Yeah, run the regression.
Yeah,
Now it's like there's so many.
because, yeah, I didn't factor in significance changing uh, based on correlation, but you're right, that could happen.
So it's basically step by step. So we should have ran a correlation, eliminated, ran another regression.
So this one went to below 2?
Right now, I just ran a regression for part B, just to eliminate that. I have curve weight, max TV movement. One point the P table, so significance 95% or 100 is 1.9.
It's weird that T-stat went down if you gave it more power, right?
Yeah, I just,
Hmm.
unless I did something wrong on this, so I have a little bit of higher. But the regression,
Yeah.
it
Good.
probably would have changed.
I don't know. I didn't. Yeah, it's usually rare that like when you take variables out that the T-stat of the other goes down, but it's possible, I guess,
Yeah, because they all,
because that one.
because now the, and this, the intercept is 23, curve weight 15, max seating is 0.78, 100 is
Yeah. So I guess what we should do next time, because we're running out of time, is uh, we'll come back here, or you can try it at home, but what we would do is look at the correlation matrix, choose between engine size and cylinders, which one to take out, which would be cylinders, and then run it again and then start again. Yeah. But to back to this part, Noble, so that's what I mean. And then for this one, so this is wheelbase versus curb weight. So this is wheelbase over here. And this is curb weight. Right? And then I take away the. So does it does it look like, uh, or is it clear that when curb weight goes up, wheelbase goes up? It is. Okay. So if, to me, well, I guess it is, but to me, this is more of like a, uh, just a bunch of noise, or not a bunch of noise. There's a correlation, but this one's clearly higher. You know what I mean? So that's what I was. I was saying like when I'm going with the interpretation, we can't have this because these are clearly correlated. Now these ones have somewhat of a correlation, but it's not that noticeable to me. Just looking at the graph, especially if you look at this part, like if you just go from like 200, 2000 to 500, it's more of just this ink blot. Um,
One of the things that we removed back.
yeah,
and it Ran a regression again with weight exercise, max seating wheelbase. The T-stat for wheelbase is 1.6.
okay,
So we would actually,
yeah,
so the theory should be run the correlation, remove the highest one, run the regression, be there.
yeah, basically. That's what we should have done, yeah.
Because when I look at it now, it's wheelbase below it. So that if we delete,
Yeah.
delete wheelbase.
Yeah, so that's the right course of action. So maybe I didn't, so this step I was just maybe getting, so if I delete these things, because this was a step ahead, and we just start with the part that the biggest issue of correlation, which was engine size versus cylinders. And then we just check engine size versus cylinders. Okay, so basically we're like start again from part B, run the correlation matrix from the reduced model, and here it is. And the biggest issue is engine size versus cylinders. So if we just address that and take out the one with the lowest T-stat, it's cylinders, right? Okay, so let's take out cylinders and run it again. I already took it out. Oh, I did take it out already. Okay, so now I'm going to run a regression with curb weight, engine size, seating capacity, wheelbase, and height. Okay, all right. Uh, data, data analysis, regression. Okay, B, this is G. Okay, yeah. So you're right. That was the. So now we just take out wheelbase and we're good to go, right? We don't have to worry about anything else. Yeah. Yeah. Assuming there's no correlations with the remaining.
Oh, yeah, because then you have.
Yeah. So this is rig 5. Okay. Um, or technically rig 6 because I skipped, but that's okay. So then we're going to take out wheelbase, right? Wheelbase goes out. Run it again. All right. So now we've got, so we only have curb weight, engine size, max seating capacity, and a hybrid. Curb weight, engine size, max seating capacity, and hybrid, right? Because we took out wheelbase and cylinders, correct? Curb weight, engine size, max, hybrid. Now we have another issue? No, we don't. That was good. Yeah. Okay, so good point. Okay, let's look at it one more time.
Do we get part A before this?
Yeah, I know.
And part two, well, if we ran the regression,
So back here, let's look at the correlations. Sorry. Oh wait, C1 to F1. Yeah. Okay, so now we're just left with uh, yeah. So small. Yeah, engine and curb weight were now the only issues, which are around 0.79. Um, and those are still pretty correlated.
but it's still.
Yeah, 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 right. Take it out. Yeah. So now it's engine size versus curb weight.
Still a lot. Good point, so.
Where's the new? Here's the one we just did, right? Yeah. Yeah. So now we take out engine size. Oops. Run it again, and then we should be, then as long as we don't lose any significance, we should be good. And then, okay, gosh. Okay, so engine size goes out. Yeah. Okay, then we're just left with E. Let's call this, is that it? That's part. Yeah. Okay.
Realistically, looking at that, when the regression. Step by step.
Yeah.
The correlation throughout the whole thing.
Well, the correlation didn't change, but we didn't know, but the significance changed when we took one out, remember?
Even then, we eliminated. Because there was
Yeah,
correlation,
that's
even
true.
though
We would have got to the same place anyways. Yeah.
But I give like,
Okay,
the end with curb weight.
for part B. So let's just make sure. So curb weight, max seating capacity, hybrid. So if I were just to do one more check, we already know the answer. Data,
Oh, that's kind of. Correlation then. None of the numbers.
yeah, it's true. That they should, yeah,
So that's kind of.
yeah,
The only thing that changed.
right.
Is there a whatever, but we still eliminate one with very high T-stat.
because it was correlated. Yeah. Okay, so we're good. So now, just to, all right, so this is correlation 3. Okay.
3 correlated.
Okay. So part B would be this one where you put in um, the model with curb weight, seating capacity, and hybrid. So just make a note that there's 2 ways to look at this. If you want the best middle model to predict Y, you want to use part A because it has a higher T-stat. You don't care about correlation. But if you want to be able to interpret the coefficients without bias, you want to use part B because otherwise those variables have correlations and you can't interpret the coefficients. So there's 2 ways to arrive at the conclusion. If you just want to predict miles per gallon, go with part A. If you want to have a meaningful, uh, interpretation of each coefficient going forward, use part B.
So part C. Reduce.
Yeah,
This,
right. Because these ones wouldn't have a proper interpretation.
and then because part D gets out of the
Okay.
the letter D, because it has engine side, we're going to use the one. Just like last
I think so, yeah.
time.
Okay, so let me stop. Kind of went way over time. Sorry. Okay, so if you're still there, I'm going to stop the recording because I've gone over by 15, 20 minutes. So sorry about that. But this will be posted for viewing. So thanks, Jordan and Michael. It looks like you're still here. Or if you're not, I'm gonna stop the recording. But I'll see you next week.